Okay, so we're going to graph these linear equations by finding intercepts. Okay, so when we have a standard the standard form of a linear equation, and we need to graph, the quickest way to do it is just identify the two intercepts, the x-intercept and the y-intercept. So what we do for that, because it's in standard form, is just take turns covering each variable. Okay, now let me remind you why we're doing that. The x-intercept is the point where y is equal to 0. And the y-intercept is the point when x is equal to 0. So, in order to substitute 0 for y, all we really have to do is ignore that entire term with the y variable in it. So, 2 minus y would be 0. Subtracting 0 doesn't do anything. We can just cover that up, and we're left looking at this one-step equation that 5x equals 15. When we divide both sides by 5, we know our x-intercept is 3. To do the y-intercept, we want to replace the x with 0. So if we put a 0 in for this x, 5 times 0 is 0. So adding or subtracting 0 there, and it doesn't affect the equation. So we can just consider that 5x gone, and we're left with negative 2y equals 15. To solve that, divide both sides by negative 2. So y is equal to negative 15 halves, or you probably prefer negative 7.5 for the purpose of graphing. Okay, so if we go locate those on our axes, and since we don't have enough boxes here, the x and y axes are already centered in the grid, we're going to have to change our scale, at least on the y-axis. I would prefer, when I'm doing this, to just change both. So I'll say my scale is 2, meaning the x scale, the y scale are both 2. Every box represents 2. So the x-intercept being 3 means there's 2, halfway to the next one would be 3. The y-intercept, negative 7.5, we go 2, 4, 6. Here would be 8. The middle would be negative 7. So it's 3/4 of the way down to that negative 8 line. Once you have those two intercepts, that's all you need to make the line. It only takes 2 points. So we just connect those, extend my line both directions, and there we go. Okay. Same procedure for question B. We're going to find our x-intercept and our y-intercept. And you're covering the opposite letter. So for x-intercept, you're covering the y term. That leaves you with 3x equals 24. So when you divide both sides by 3, we know x is 8. For the y-intercept, we ignore the x term. That leaves us 6y equals 24. Divide both sides by 6, y is 4. So again, with an intercept of 8, I can't count by ones, so I'll say again that my scale is 2. The y-intercept is 4, so that's 4. The x-intercept is 8, so 2, 4, 6, 8. And there we have our line. Oops, still one square. Line, just like so. Question C. We need, again, two intercepts, the x-intercept and the y-intercept. For x-intercept, we cover the y. That gives us 6x equals 3. Divide both sides by 6. X is 1/2. for y-intercept, cover the 6x term. We're left with simply y equals 3, which is our y-intercept. Here, we can fit both of those on our graph if we count by ones. So x is a half, and y is 3. So those 2 points are enough to make our line. Okay. Question D. Getting ready, I need an x-intercept and a y-intercept. For x-intercept, I cover the y term. So x is equal to 12. No solving necessary, it's already done. For the y-intercept, I cover the x's. So I'm left with negative 8y equals 12. When I divide both sides by negative 8, y is equal to negative 1.5. So, again, I'm going to have to change my scale here to fit 12 on there. So I'll make my scale 2. So the x-intercept would be 2, 4, 6, 8, 10, 12. The y-intercept negative 1.5. That should be enough to give us our line. Okay, number 2. Now we're going to look at some real world scenarios and we're going to write inequalities for them. Okay, an inequality means your choices are you're going to write a less than, a greater than, less than or equal, or greater than or equal for each of these problems. We're not going to solve anything, just set them up. Okay. So Karen mows lawns and babysits to earn money. She earns $12 per lawn. That sounds important. $20 per babysitting job. She wants to earn at least $400. At least. That means $400 or more than that. So we're going to set up an inequality to represent the amount of lawns and the number of babysitting jobs she needs to do. Now, we don't need to write let statements because they're already done. The lawns is X and the babysitting jobs is Y. Okay? So for each lawn, I'll get $12 and I'm going to do X of those. So 12X. I'm also going to do some babysitting, or Karen is going to do some babysitting, and she will earn $20 Y times. So we're going to add on to our lawn money $20 for each babysitting job, of which there are Y. Now when we add those two values together, we want that to be at least, at the least, at the lowest. So we want this money we earn to be greater or equal to $400. Okay, so what we did here was our lawn money added to our babysitting money needs to be greater or equal to our goal. B, Gary wants to buy Jolly Ranchers and Starburst. Jolly Ranchers cost 25 cents each. Starburst cost 15 cents each. He can spend at the most, $12, meaning my total, when I add all my candy money up, has to be $12 or lower. Right, an inequality represents how many Jolly Ranchers, which is X, and Starburst, which is Y. Okay, so the money I spend on Jolly Ranchers plus the money I spend on Starbursts can be at most $12. It can be lower or it can be exactly $12. Right, so how much am I spending on Jolly Ranchers? They're 25 cents each. I buy X of them. That's 0.25, 25 cents times X. We're going to add to that all the money we spend on Starbursts. Well, they are 15 cents each. We buy Y of them. So 0.15, 15 cents for every one of those Starbursts, less than or equal to $12. Ashley's buying tickets to the movies. She can spend at most $100. Adult tickets are $9.50. Child tickets are $5.50. Right, and inequality represent the amount of adult tickets, so there's X, and children tickets, Y, she can purchase. So my plan here is the money I spend on adults added to the money I spend on kids can be at most $100. At most means at the most. It can be that much or lower. So all this money I spend, less than or equal to the $100. So how much money do I spend? Well, every adult ticket is $9.50. I get X of those. So $9.50 X plus each child ticket is $5.50. I'm going to get Y of those. So $5.50 Y is less than or equal to 100. Okay, next one, Alexis wants to purchase shirts and pants. She has no more than $150. No more than. So that means I can spend less than $150 or I can spend exactly $150. So less than or equal to $150. Shirts are $12 each, pants $22 each. My shirts, I'm going to buy X of those. Pants, I'll buy Y. So the money spent on pants, I guess shirts was given first. So the money spent on shirts added to the money spent on pants can be less than or equal to $150. Since shirts are $12 each and I get X shirts, that's 12X. I add on some pants. Pants are $22 each and I get Y of those. So 22Y has to stay under or exactly $150.